last thing we need to talk about in today's lesson is the graph of the logarithm graph. Now, we already talked about that logarithms are inverses of exponentials. So you should notice that as we talk about the logarithm graph, it has a lot in common with the exponential graph. In fact, it's almost the same thing except for the x's and y's have been flipped. So if you remember, for exponentials, we had a horizontal asymptote. For logarithms, I now have a vertical asymptote. They're flipped. And whereas the asymptote for exponentials was y equals 0, the asymptote for logarithms is x equals 0. Now look at our first point. Remember, the first point for exponentials was 0, 1. If you flip that, this point is going to be 1, 0. And the last point on our logarithms, for exponentials, it was 1, the base. So for this one, it's going to be the base, 1. And those are all the basic features of the logarithm graph that you need to have memorized. You need to know. So what I'm going to have you start with is here in example 7, example 8, I would like you to just start by graphing log base 2 of x. So forget the plus 3 and minus 1, forget the 1 and the negative for now. I want you to just practice graphing the basic logarithmic graph using those 3 rules. So we'll pause the video, try to graph log base 2 of x on both of these, and then come back to check and see how you did. Let's see how you did. We know that all logarithms have a vertical asymptote at x equals 0. They have the point 1, 0, and they have the point base, 1. The base for this is 2, so that's why I put the point at 2, 1. And then I did the same thing down here for the same log base 2. Now, what I would like to do is graph this final example 8 together. So let's look at our transformations. I have this 1, and I have this negative. So a 1 on the outside is going to move up 1. A negative on the inside is a reflection side to side. So I'm going to take all these points, I'm going to reflect them first side to side, then move them up 1. So let's start with my asymptote. It doesn't really make sense to reflect my asymptote side to side when it's already centered. And if I think of moving this asymptote up 1, that doesn't really change it because it's a forever line. So let's go to my green point. Reflected across, up 1. Beautiful. Blue point reflected across, up 1. So then we have the shape of our transformed graph, which should be 1 plus log base 2 of negative x. And there we go. Now, having done that one, I would like you to try example 7. So outline what that plus 3 and the minus 1 does, and then do that to your asymptote and your points. Then come back to check and see how you did. Okay, let's see how you did. I have my basic exponential. I wanted to move my asymptote left 3, so I did. Doesn't really make sense to move it down 1. Green point left 3 down 1, and blue point left 3 down 1. And that gives me that shape. Now, let's do one more thing on these. We're going to practice stating the domain, that was the word domain, the range, and my asymptotes for each of these graphs. And we're doing it for the transformed graph, not the original. So as I start by looking at this one, the domain is my side to side. So my domain is going to be from -3 to infinity. Those are the x values. I go here from -3 and then keep going to the right to infinity. I'm not going to include -3 because it's an asymptote. Now let's look at the range. Range is up and down. So if I look at this graph, the up and down, it goes down forever, and it's going to go up forever. It's going to go up pretty slowly, but it's still going to go up forever without stopping. So there's my range. And my asymptote is going to be x equals, because it crosses the x-axis, x equals -3. So I would like you to pause the video for a moment and try to do the domain, range, and asymptotes for example 8. Let's see how you did. Now remember, we're looking at a transformed graph, not the original. So my domain is -infinity up to 0, not including 0. My range is -infinity to infinity because it's everything up all the way, down all the way. And the asymptote is still right there at x equals 0. So now that you have all that, you should be pros at graphing logarithms. That means we are done with lesson 4.1. In the lesson 4.2, we'll do exponentials and logarithms in a little more depth.